Hey everyone. I'm super excited to be here. It's actually my second time and it's twice as fun. My name is Amit. I work at DAS and I basically really love Python. So today we're gonna talk about sassy SaaS integrations. And before I start, I just want to say thank you to the PyCon organization and Sam about everything. It was wonderful. Great. So before I talk about the real issue, which is SaaS integrations, I want to understand why we have this issue. So here at DAS, we build in the cloud remediation cloud, the remediation cloud basically. And that means that enterprises that have a bunch of tools and a lot of developers equals tons of alerts. And we basically help them fix these alerts. And before we help them fix the alerts, we need to actually consume these alerts and this information into our own cloud. And therefore, basically right now, there are a lot of security tools and developer tools that we need to integrate with. For example, we need to integrate GitHub for the dependable alerts, or we need to integrate Snyk for the issues, for the SCA. So, well, let's talk about the agenda. We're going to talk about integration in general and how it works, how we do API-based integrations, and what are the main obstacles, both in fetching the data and doing the ETL afterwards. And later on, we're going to talk about Airbyte as a use case of how a really cool company solve this generally for almost every kind of integration. And what can we learn from its SDK? Later on, I would like to share a bit how we solve that issue at DAS and how we built our own SDK for that. And I will show some cool tricks. For example, module discovery and dependency injections to make the developer life easier. Later on, I will finish with showing a cool tip on how to make automated snapshot testings for integrations. Great. So each integration has its own story. You almost all the time need to implement authentication, which is either token or OAuth based. You need to implement pagination that might be cursor or by page. And same goes to rate limits and having the data 400 status code. Also for versions. So I guessed many here integrated something and had the schema of that integration changed without noticing. And the most important part is the schema itself, how to save the right schema so we can ingest it later. So basically, handling data is an art, and it's fun because every time I move between jobs, I have the same problem, which is how to handle integrations, how to handle the ETLs. So basically, I want to drill down about the real obstacles. And when fetching an integration, you always need to do the same things all over again. You need to make sure that the time windowing is right, so you fetch only new data. And also, same goes for pagination. You need to make sure you don't spam the API and cause rate limits or even throttling. You need to make sure that you handle the right exceptions of, for example, validations or even internal server errors gracefully, and monitor them using metrics and even traces. For validation, you need basically after you fetch the data, so you don't need to trust the third party. You can validate the code. You can do JSONSchema or something like that, and you make sure that you got enough data to continue working. And if not, maybe you need to crash it. Regarding parse, so let's say you fetch the data, and for example, let's take AWS resources from Boto3, for example. While that's on the AWS domain language, it's not really the same as the DAS domain language. So we need to parse the data and make sure that we convert the data in a manner that our backends will able to work. And also we need to handle issues, right? So let's say I got an issue in my code and I wrote the integration bad. I need to be able to restream everything without fetching all the data again and again. And the last part that we won't talk about it, but it's really an issue, is how do I store the data? Do I use data lake like S3 and Athena? Or I use data warehouse and maybe RDBMS? And what happens when something fails? Do I get duplicates in my database? So these three issues are really hard. Okay, so when I joined DAS, I did a little digging in the code, and I found two integrations that we have, which is one is the AWS and the second one is GCP. And naive me thought, okay, it's gonna be the same, right? It's almost the same, but I saw that a developer wrote the AWS integration and saved all the data as a one big JSON file, which can be huge. And another developer was more responsible and splitted the data by GCP projects, but it saved it in CSV file. So there is no consistency. There is no framework around it. And we understood that's a really issue. And we wanted to create some kind of SDK or a framework so it will be very easy to write integration and fill that awesome integration page. So I took a little digging, and honestly, I found I'm in the area of integration quite a while, and one company that is really interesting, in my opinion, is a company called Airbyte. So in the world of ETLs, there are some competitors. There is, for example, Fivetran, which give you ETL as a service and let you integrate everything to everything. And then came Airbyte and did disruption to this world. Basically, what Airbyte gives is an ecosystem around connections and destinations, and they let you connect almost everything into almost everything. And the nice thing about it, and why I'm talking about it in this specific meeting, is that they build everything on open source. So basically, people around the world build connectors for them. And that's amazing. They have a great investment in that. And they created something called CDK, a connector development kit. And I wanted to talk about that because there are some really cool concepts in their CDK that we later on used at that. Okay, so let's dive in. The CDK must handle the integration, right? It must query the API, and handle pagination and everything, and even exception handling. And in order to manage that, the Airbyte CDK has a concept of a source, which is a class. As you can see, for example, this is a code from the Monday source, and you can see that this source defines only two things. It defines the check connection to make sure that the authentication token is correct, and it defines the streams, which entities you need to fetch for Monday. So in this example, you see there are 5 entities later on, and each one does the API fetching and everything. As you can see, each item is a stream. So that's the second logic that Airbyte defined. And what is a stream? A stream is basically a way of handling the API requests. So in this example, I should actually change it. It's not Monday, now Jira. And this is a stream of how to fetch data from Jira. And as you can see, there is no request.get because this SDK does everything for you. You basically need to handle out-of-the-box functions such as what is the base URL, how to fetch, how to find the next page, for example, from the response, and how to parse the response. So I really love that abstraction they created, and they give me quite a lot of inspiration about it. And basically, we use these kind of parts to create our own SDK. So we went on a journey to build our own DAS framework. And this framework needs to enable developers to write integration quickly, to deliver fast. And we decided something that is different from Airbyte, that will split integration into two phases. The first phase is a stream, like Airbyte did, which maintains the incremental fetch and the state and pagination and all that annoying stuff. And then we save the data as is, raw, from the API. The second phase is the parse. We convert raw data to the DAS domain objects and basically then ship it to the backends, and then the magic happens. And the nice thing about it, again, is that things can be restreamed, and it's fine. We don't need to get throttling because we want to restream the entire data for a customer, for example. Okay, so how it works? Basically, as a developer, you need to do two things. You need to create for example, a folder for the, let's say, sneak integration, and you need to create an integration.py file. In this file, you need to create a class that inherits that abstract integration class from our SDK. And inside this class, you basically define the streams. As you can see, there are stream of an issues, sneak issues, and sneak project, and you define parsers. So for this example, we take the issues streams and the project streams and return output, which is sneak findings. And maybe this parser knows to cross the data and manipulate it for our own needs. And there is no definition of how to fetch data, right? So the stream is the same, it's almost the same like the Airbyte. I won't talk about that. But one thing that I do want to talk about is how do we run this? Because it's a file with a class, that's it. So this is a cool trick that actually I saw in other frameworks like Kubeflow pipelines, for example, that they have some kind of CLI that automatically detects the code and runs it. And when I saw it first, I thought, whoa, magic, that's really cool, let's do it. No one will need to create a CLI anymore. And so I dig up to understand how it works. And this is the first trick. And we do something that called class discovery. We use the package import lib to import the integration.py file into the memory. And then we use the inspect package to find the class that inherits abstract class. And then we use a really cool package that's called typer, which is the other of this package, the same order of fast API, to create a CLI. So if we go bottom up, we see that we run typer around across the main function. And then we can see that we go to the get source object function, which does the import lib. And once we get it, we get a model object. And then we can iterate its members, and a member can be a variable in this file, for example. And once we found a member that is a class and inherits the abstract integration, we fetch it. And then we run it with the configuration, for example. The second trick that we created is using dependency injection to abstract all the pain away from the developers. So if someone used, for example, Fast API, he saw things like that. So basically, as a developer, in the parser side, I need to tell the SDK what data I need to fetch. So for example, to parse sneak, I need to fetch a full refresh of the project stream, and there I used here generic typing of Python. And for issues, I want only the new data, the incremental data, using the issues stream. So basically, when I run it by itself, I need to provide all these kind of classes. But in real time, when I use this code with our CLI, we automatically understand the typing of this function. We fetch the data because we know that we got full refresh for the project and incremental for the issues. And once we got the data, we bring it to this function. And It's really cool, actually. So in order to implement things like that, we will use inspect again. Basically, what we did here is to create a class that uses generic typing, just like Java, for example, and uses some kind of a type file. And then, let's say we have a stream, and we have the parse function. We use dependency injection. So we read the signature, the typing of the parse function, and we iterate it. We find if one of the typings is a full refresh, and then we fetch using get args, inspects, get typings, get args, the subclass in the thingy right there. And once we got it, we can run the full refresh later on and then give it to the actual function. So that's about it. The last trick that I want to talk about is how to ease the pain of testing. So let's say we got a lot of integrations, and for each integration, we need to fetch APIs, save it in a file, then run it in the test to make sure that we got everything right. So in order to automate this one, we actually used the request package hooks. So in our test, we got like a special process that we can run it, and it really runs the integration with some kind of our token, for example. But using the request hook that you can see here, we add a function that takes the response, save it in a JSON file. And the nice thing about it, that if you run our integration with this code, after running, we get a list of JSONs that we can use to mimic the tests. So in order to mimic the test, there is a really cool package that's called request mock that actually takes the files, understand the URLs that need to be mocked, and basically run the tests. So let's summarize. Solid frameworks means happier developers and faster development and delivery times. And the typing systems in Python really can help us to abstract the pain. And good APIs really abstracts all the crappy stuff and gives you the flexibility to do whatever you want. And it's limitless. Thank you very much.